NASA made this cool rover called Curiosity and sent it to Mars to see what else we can find out about the red planet, the one that will possibly become our next home. Curiosity has been exploring the surface of Mars, taking measurements, and gathering data about the planet for more than 10 years. And good old Curiosity stumbled upon some interesting wave-rippled rocks in the region of the Martian surface that was kind of expected to be drier. Scientists believe this area was actually a lake bed. It might be the bottom of a dried-up lake and all that sediment and other things that have accumulated there. All this can give us some important clues about the history of the lake. For instance, the types of organisms that might have lived there, how deep the lake was, how long it was there, and similar stuff. These wave-rippled patterns tell us that these rocks may have formed when strong Martian winds were moving the water in this big ancient lake. You know that specific sound you can hear when you're holding a seashell to your ear? You actually hear it because of the way the air gets trapped inside the shell and moves against its walls. The air cannot escape, so it vibrates at frequencies that depend on the size of the shell. In other words, you have a feeling you hear the sound of waves hitting a shore. That's Mars in my imagination now, a spot where you can still hear the long-lost sound of waves crashing against the shores of mysterious gigantic lakes. During its mission, Curiosity also came across a metallic object which turned out to be a meteorite. This unusual rock that came from space is made of nickel and iron. Its name is Cacao, and it's about the size of a small car, 6.5 feet long, and weighs over a ton. This is an important discovery because we don't often find metallic objects on the Martian surface. Most of the rocks there are made of basalt or some other volcanic materials, so that chunk of metal could tell us more about the history of Mars and how it formed. Plus, it definitely stands out. The surface of Mars is red from oxides, while Cacao is metallic-looking and dark gray. It's rounded and smooth, too, which means it once passed through Mars's atmosphere. There have been other robots exploring Mars, too. For instance, NASA's Mars Reconnaissance Orbiter, MRO, stumbled upon circular sand dunes. Sand dunes are usually very common on the red planet. They come in many different shapes and sizes, but circular ones like these are really rare. They consist of dark sand with light-colored material surrounding them. And the cool thing is that these dunes are arranged in a specific pattern, similar to the spokes of a wheel. It could be because of the way the winds blow. But back to our buddy, Curiosity. It's been exploring many other interesting things, like oxygen levels in the Martian atmosphere. The levels change depending on the season. There's more oxygen in the spring and summer. It's still not clear why, though, and of course, even that is not enough for us to really breathe there. The concentration of oxygen on Mars is 0.1%, which is about 100 times less than the concentration in Earth's atmosphere. The atmosphere of Mars is mostly made up of carbon dioxide, with traces of other gases. Curiosity was so good that it also decided to analyze the age of rocks it found. It seems they're much older than we previously thought. Some of them date back more than 3 billion years. Curiosity found organic molecules in soil samples too. These molecules are basically building blocks of life. Now, this doesn't prove there's indeed life on Mars. It's just one of the things that suggests there might have been some form of life a long time ago. Curiosity discovered potential evidence that there might be a large reservoir of liquid water beneath the south polar ice cap, probably very salty and full of different minerals. This high salinity is the reason why this water could remain liquid at temperatures well below freezing. It would be cool to have some sort of subsurface ocean to take a dip in, especially when these crazy Martian winds are raging on the surface. And it would be great to have something that would protect us from those insane radiation levels on the red planet. There are some pretty toxic chemicals and salts in the Martian soil, which can be really bad for humans. Astronauts could potentially end up being exposed to these toxic chemicals, either through direct contact with the soil or by inhaling dust that contains these salts. Also, these substances could be a problem for growing crops. This is a really big discovery for long-term missions to Mars, because astronauts would need to be able to grow their own food so they can survive while there. Another thing that favors the idea of potential life on Mars is discovering methane there. Methane is a very important finding because usually living organisms produce this gas. So, where did it come from if not from them? In reality, there are a few possible explanations for that. One is the geological activity of underground reservoirs. Another idea is that meteorites brought methane to the red planet. What's interesting is that levels of methane are higher in particular areas. So, yeah, I don't know about you, but I'll stick to the theory that it comes from living organisms. Now, it's possible that volcanoes on Mars are still active. We know there are many extinct volcanoes on the red planet, but we've never found enough evidence to prove that some of them are still alive. Scientists studied volcanic deposits and found out that some volcanoes could have erupted maybe 50,000 years ago. Before that, everyone thought the last eruption happened 3 to 4 billion years ago. If you could compress the geological history of Mars into just one day, this would be like having an eruption a second ago. So, you never know. There might still be magma bubbling in secret under the Martian surface. All the future generations that might end up building their life there could really have some fun. Mars turned into a cold and barren place that can't really support life over time. And one of the main reasons for that was losing its atmosphere. The red planet used to have a much thicker atmosphere, similar to Earth's. One major reason for that is its relatively weak magnetic field. Earth's magnetic field helps protect our atmosphere from the solar wind, a stream of charged particles that comes from the sun. Without this protection, Mars had nothing to help it confront this insanely strong force that eventually took away most of its atmosphere. Another factor that played a big role in the loss of Mars's atmosphere is its relatively low gravity. Because Mars has weaker gravity than Earth, it's easier for gas molecules to escape into space. So Mars probably used to be more similar to our home planet. But with its current thin atmosphere, it can't keep any heat, which makes it very cold and very complicated for us to explore. But maybe it's better for us that we didn't visit the red planet back in its old times. There's this story about an ancient megaflood that might have happened there. So yes, the red planet probably used to be a wetter and more hospitable place than it is today, with beautiful flowing rivers and amazing lakes, ponds, and other bodies of water. And some research showed evidence of large channels carved into the planet's surface. These channels are way bigger than any we previously found on the planet. They suggest this megaflood happened billions of years ago. Perhaps it happened as a result of different factors, like volcanic activity, melting ice, and the release of carbon dioxide from the planet's crust. The flood may have created some temporary pools of water, too. Hopefully, it will mean more interesting clues for finding traces of microbial life. How about that?
If you're scared of spiders, never ever visit Mars. In March 2025, NASA's Perseverance rover found something looking like a bunch of tiny spider eggs on the surface of the red planet. This something is made up of hundreds of little round balls stuck together. What if all these eggs hatch? Will hordes of 8-legged creatures swarm the red planet? Doubtful. The thing found by Perseverance was just sitting there on a hill called Witch Hazel, near the edge of Jezero crater. On closer inspection, it turned out to be a weirdly shaped rock with a bit of Martian dust on it. Yeah, sadly, or luckily, those weren't Martian spider eggs. Even so, the formation really stood out from everything else around it. The Perseverance team named the weird rock St. Paul's Bay. It's what scientists call a float rock. This term means that it didn't form where it was found, but somehow got moved there. So, at the moment, we don't have enough clues to figure out its background and how it got that strange texture. But that's not the only mystery. Something had to move this rock from its original spot. One theory claims that the rock could have been created when a meteorite smashed into Mars. The powerful impact must have blasted rocks into the air, and those bits could have cooled down and formed the tiny balls we see now. If that's true, this rock might have come from really far away, and it could give us new info on how big impacts move stuff around on the red planet. NASA thinks the rock might have just rolled down Witch Hazel Hill. It could have come from one of the darker layers up on the hill. We have seen those layers from space. Now, the goal is to study Witch Hazel Hill more closely and find out if those layers are made of the same stuff as the St. Paul's Bay rock. If so, it might mean a few things. Maybe there was volcanic activity in that region, or a big meteor hit, or there might have been groundwater there in the past. If this theory turns out to be true, there's a chance that some of those rocks might hold tiny fossils from ancient microbes. That's why NASA is planning to bring some of the rocks back to Earth in the 2030s with the Mars Sample Return mission. We'll get to study them up close and maybe, just maybe, find signs of ancient Martian life. Now, the funniest thing about it all is that it isn't the first time scientists have dealt with arachnids on Mars. Spiders on Mars is actually the nickname for a weird-looking surface feature. In certain places on Mars, you can see big dark cracks that spread out like spider legs. Some are huge, over 3,000 feet wide. From above, they seriously look like a bunch of creepy crawlers moving across the planet. These spooky shapes were first spotted by Mars orbiters in 2003, and they've been showing up in satellite photos ever since. At first, no one had a clue what they were, but now, scientists think they form when carbon dioxide ice, dry ice, sitting on the surface, suddenly turns straight into gas. That fast change causes gas to shoot through the ice and carve out all those strange crackly patterns. An even cooler thing is that NASA scientists have been able to recreate those Mars spiders in the lab here on Earth. They built a special setup mimicking Mars's surface and watched tiny versions of the spiders form right in front of their eyes. The team had been trying to recreate those Mars spiders for 5 years. When it finally happened, they were overjoyed. Back in 2021, scientists managed to explain how those spider-like marks form on Mars using something called the Kiefer model. The basic idea is that in spring, sunlight shines through big, clear chunks of frozen carbon dioxide, aka dry ice. That heats the Martian ground underneath, and the ice starts turning straight into gas. The gas builds up under the ice, and when the pressure gets too intense, boom, the ice cracks. Gas shoots out, dragging dark sand and dust with it, leaving behind those spooky spider patterns once the ice melts in summer. The team tested this theory using a big special chamber nicknamed Dusty. Yeah, that's a real name. It's about the size of a barrel and can recreate the freezing cold, super low pressure conditions on Mars. We're talking about -301 degrees Fahrenheit. The researchers also put fake Martian soil in the chamber and covered it with CO2 ice. Then they used a lamp underneath the soil to heat it up, just like the sun heats up Mars. Their experiments worked, and little spider shapes formed just like they do on the red planet. The study also revealed something new. The team found that ice formed inside the ground too, and it caused the soil to crack along with the ice. This might explain why the spider's legs are so zigzagged instead of straight, like we might expect. Next, they want to keep doing experiments to figure out more about the Martian spiders, like why they only show up in some places on Mars and why they aren't getting more common over time. The red planet is apparently set on playing tricks on people from Earth. For example, in April 2023, NASA's Curiosity rover took a little break from searching for signs of ancient water on Mars and stumbled upon something curious: a travel book. Later, scientists realized that it wasn't really a book, just a rock. But it does look like a little hardcover with a page frozen mid-turn. This book rock is tiny, measuring only about 1 inch wide. So it might not hold any ancient Martian stories, but at least it's travel size. Then in January 2023, the University of Arizona shared another bizarre image: a rock formation that looked like the face of a giant teddy bear. It had two distinct beady eyes, a button nose, and an upturned mouth. It was captured by NASA's Mars Reconnaissance Orbiter, which was orbiting the red planet at the time. Scientists from the University of Arizona explained that the teddy bear face was likely just a natural formation, like a broken-up hill or mound in the center of an ancient crater. Another cool find occurred in February 2022. The Curiosity rover spotted something that could only be described as a tiny flower made of minerals. It looks like little coral branches, but it's actually a mineral deposit, which is pretty rare to see in a flower-like shape. Most of these kinds of deposits are formed when ancient water mixes with rocks on the Martian surface, so they're not exactly new to scientists. But this one is unique, since it looks like a tiny plant or flower. Now, the next discovery is even wilder. Once, the Curiosity rover snapped a pic of what looked like a perfect doorway in a Martian cliff. Naturally, people started wondering if it was some kind of secret entrance or maybe a hidden base for astronauts. But in reality, it's just a really cool rock formation. Winds and erosion carved away at the rock over time, creating a perfect symmetrical shape. Going even deeper into the past, back in 2018, a researcher noticed weird stick-like shapes in an image and thought they looked like fossilized animal footprints. Unfortunately, NASA quickly shot down the idea. Those tracks turned out to be salt deposits that formed in areas where water evaporated. You can find something similar on Earth too, for example, in dry lake beds. So, while it's pretty interesting that there's more proof that Mars used to have rivers and lakes, these tracks aren't evidence of life, just a quirky rock formation. Now, the next find is absolutely amazing. NASA's Opportunity rover found round, blueberry-like rocks on Mars back in 2004. But those aren't the kind you eat with your cereal. The blueberries you're looking at are made of iron, and they're evidence that Mars used to have a lot of water. Over billions of years, water smoothed them out and created these little balls. Scientists think that they formed when Mars was much wetter than it is now. The iron-rich blueberries are a pretty big deal because they show that Mars could have been a very different place a long time ago.
Have we found another civilization? Is that a door to someone's home on another planet? Can we peek through the windows? After all, it was NASA's Curiosity rover that sent this image to Earth, and right now, this rover is exploring the surface of Mars. Unfortunately, astronomers were fast to disappoint us. They claimed that it was just a natural part of the Martian landscape. There are several clues that made them think it wasn't a real door. For example, it's tiny, a mere 3 feet high. But it might simply mean the Martians aren't that tall, you may object. But scientists keep insisting that what looks like a door is actually an opening in a rock created by natural forces, like winds and erosion. The thing is, if you look at the rock attentively, you may notice strata, the layers of silt that stand out because they're harder than the surrounding material. These strata dip here on the left and a bit higher on the right. They likely appeared around 4 billion years ago in a river or a wind-blown dune. Since the strata became visible, powerful Martian winds have eroded them even more, and now you can see that they disappear inside the door. And look at this. See those cracks? Yeah, those. That's how rocks weather on the red planet. This small cave probably formed when several fractures crossed the strata. A pretty large boulder might have fallen out under its own weight, and this created the door-shaped opening. Now, this theory is quite plausible, because even though the gravity on Mars isn't as strong as on Earth, it's still strong enough to do it. Besides, see that rock to the right of the opening? It has a suspiciously smooth vertical edge. It must be the culprit. It probably fell out not so long ago, and Martian winds haven't got rid of it yet. And winds on Mars can be exceptionally powerful. This planet is infamous for its intense dust storms. Sometimes they kick up so much dust that you can see it through a telescope on Earth. Such storms occur every year and cover continent-sized areas. They also last for weeks at a time. But besides these annual storms, there are even larger storms that happen much more rarely, but they're more powerful and way more intense. Those are called global dust storms because they encircle the entire planet. But even if you got caught in the most severe storm on Mars, it wouldn't be as terrible as you might think. The wind speed on the worst Martian storms reaches 60 miles an hour tops. Hurricane-force winds on our planet can be twice that speed. You should also keep in mind that the atmosphere on the red planet is 1% as dense as the atmosphere on Earth. That's why, if you decided to fly a kite on Mars, you'd need the wind to be much faster than on Earth. Otherwise, you wouldn't even be able to get the kite in the air. In other words, even though it's quite windy on Mars, it doesn't feel as intense as on our home planet. Oh, by the way, you might have noticed I keep calling Mars the red planet. Why? Look, our neighbor is covered in dust, soil, and rock that is rich in iron oxide. That's what gives the surface of the planet its trademark red hue. And look, there's the trademark. Nah, just kidding. Mars is the fourth planet from the Sun. Not so far away from the star, you might say, and still, it's a cold and deserted world. The average temperature on its surface is minus 81 degrees Fahrenheit. But if you ever visit one of its poles during the wintertime, bring a lot of warm clothing, because the temperatures are likely to drop to minus 220 degrees there. In the summer, though, you might feel very comfortable in some regions. There, the temperatures can rise to 70 degrees, not very different from what we're used to. Mars is one of the most explored space bodies in the solar system. At the moment, NASA has 2 rovers roaming the red landscapes, Curiosity and Perseverance. There's also one lander called InSight and helicopter Ingenuity nicknamed Ginny. Perseverance is the most advanced and largest rover ever sent to another world. The journey to the red planet took 203 days, and Ginny traveled to Mars attached to the belly of Perseverance. Sounds cozy. And now, I'm going to tell you something really curious. Let's say you're a Babylonian who lived around 5,000 years ago. Babylonia was an empire in ancient Mesopotamia. Just think back to 6th grade. Anyway, your neighbor comes up to you and says, "What day is it today?" And what do you answer? "It's Mars Day." Wait, what? When the ancient Babylonians created the week, they decided to divide it into 7 parts. Each day got named after some space body, like the Moon, the Sun, Venus, and so on. Mars Day was on Tuesday. The Babylonians believed that each of these space objects influenced their lives on the day named after it. And since Mars was red in color, they associated it with aggression. That's why on Tuesdays they had special ceremonies to avoid the influence of the unfriendly planet. Indeed, Mars might seem unfriendly to a tired traveler. Its atmosphere is very thin. Its volume is a near 1% of the atmosphere on Earth. In other words, there's 99% less air to breathe on the red planet. Mars's atmosphere is mostly made up of carbon dioxide. At such high concentrations, it's toxic for us humans. And if you were looking for some oxygen to breathe on Mars, you'd come away empty-handed. There's only 0.1% of oxygen in the air on the red planet. That's definitely not enough for you to survive there. At the moment, Mars has 2 moons, Deimos and Phobos. Astronomers think they may be asteroids once caught in the gravitational field of the planet. The moons are shaped like potatoes. That's because their mass is too little for gravity to give them a spherical form. Potatoes, eh? Maybe they should be renamed mashed and au gratin. One day, Mars will get a ring of its own. It might happen in the next 20 to 40 million years. Will Brightside be there? Stay tuned. Mars's gravitational forces will tear apart the planet's largest moon, Phobos. Hey, it really will get mashed. Some chunks of the former moon will crash into Mars, and others will break apart and create the ring around the planet. This ring might exist for at least 100 million years. The surface of Mars is cut by a huge canyon system known as Valles Marineris. Sounds like a pasta sauce. If it were on Earth, it'd stretch all the way from New York to California, over 3,000 miles. At its widest part, the largest canyon on Mars is 200 miles, and it reaches 4 miles at its deepest point. If you still have difficulties imagining the sheer size of this natural phenomenon, here you go. Valles Marineris is 10 times the size of the Grand Canyon on Earth. Now, since we're on the subject of gigantic things, let's talk about Olympus Mons. This is the largest volcano in the solar system, and it's on Mars too. It's 3 times as tall as Mount Everest on our planet, and that's the tallest mountain above sea level. And the base of Olympus Mons is as large as the state of New Mexico. Now, scientists think there could have been water on Mars in the past. What made them think so? They found lots of ancient river valley networks and lake beds on the surface of the red planet. Plus, on Mars, there are minerals and rocks that could only form in liquid water. Mars might even have experienced terrible floods 3.5 billion years ago. These days, there's still some water on the red planet, but Mars's atmosphere is too thin for this water to stay in its liquid form on the surface. Now, it only exists in the form of water ice. You can find it just under the surface of the planet in its polar regions. The only place where this water is visible is at the North Polar Ice Cap. Also, sometimes, salty water flows down crater walls and hillsides, and there are tiny quantities of water in the planet's atmosphere, but it only exists as vapor. So, as a vacation spot, I think I'll pass. Recently, scientists have made an astounding discovery that can change the entire course of Mars exploration. Apparently, there are oceans of liquid water on the red planet, so the future looks bright. We could use this water to support future missions, and then even relocate to Mars since we wouldn't need to worry about where to get this precious liquid, right? Well, there's one big problem. These oceans of liquid water are in Mars, so deep inside that we aren't likely to get there. At least that's what a new analysis of seismic data collected by the Mars Insight lander claims. Huge reserves of liquid water seem to be the best explanation for some seismic quirks of the red planet. So all this precious water is out of our reach. But we need to find it to solve the puzzle of the aquatic history of our blushing, dusty neighbor. And the first thing we need to do is identify where the water is and how much of it the planet is hiding.
Navigation has confirmed that the parachute has deployed and we are seeing significant deceleration.
Now, our rovers are scurrying about on the surface of the red planet, gathering all the available data on the planet's surface geology. And it's getting increasingly obvious that Mars was once covered with water. Many factors, from Martian terrains to ancient dry lake beds and deltas, suggest that there was a time when the planet was quite soppy. These days, there's still some water on and right below the surface of Mars, but it's in the form of ice and nowhere near what Mars had in the ancient past. To understand how much of it could have been on the red planet billions of years ago, we must know where all this water went. There are 2 spots where the water could have gone: into space or toward the interior of Mars. Then it could have been isolated as either liquid reservoirs or ice deposits. Currently, we don't have any way of measuring how much water once leaked away. But now, we finally can find out more about the gooey center of the red planet. All thanks to the Mars Insight lander. It isn't operating anymore, but from November 2018 to December 2022, it was listening to the hums and rumbles and monitoring the activity below its feet. The thing is, acoustic waves generated by seismic activity deep inside the planet can change according to the composition and density of the material these waves are moving through. And scientists can get a lot of information analyzing the behavior of seismic waves. In this case, they used a model similar to those used to map underground oil fields and aquifers on our home planet. Then, with the help of this model, they analyzed the data gathered by InSight on Mars. They discovered that the best explanation could be that there was a layer of fractured rocks whose cracks were filled with water deep under the surface of the red planet. That layer could be at a depth of 7 to 12 miles. That's why it would be extremely tricky for future missions to get to it. And still, the new discovery could help us understand the Martian water cycle. Confirming the existence of a large reservoir of liquid water can help us sneak a peek at what the climate on Mars used to be, or what it could be like one day. And if once Mars had a lot of water, it could have been habitable in the ancient past and might become habitable in the future. Water is crucial for life as we know it, so underground water reservoirs on the red planet could already be habitable. Maybe, while we're talking, tiny microorganisms or even some tentacled creatures are living their lives in the comfort of their underground home. On Earth, super deep mines do host life, and the bottom of the ocean, with its immense unbelievable pressures, isn't lifeless either. So far, we haven't found any evidence of life on Mars, but for now, it sounds like this place has the potential to sustain life. InSight data has shown that there isn't likely to be a lot of water ice in the upper crust of the planet, at least in the region around the lander. But if it turns out that there is a water-rich layer deep below the surface and stretching around the entire globe of the planet, then there would be enough water to fill ancient ocean beds and even more. Now, Mars isn't the only place outside Earth where there is water or where we might one day find water. Take the good old Moon, for example. On Earth's natural satellite, water can be found all over the surface, but it's not the water you might be imagining. On the Moon, water remains mostly as ice, and it's distributed unevenly. For example, the poles of the Moon are the regions that never receive sunlight. This is the reason they're extremely cold, and it's no wonder there's a lot of ice there. The ice in these areas is often mixed with the lunar soil and hiding deep below the surface. Then there's Enceladus, the sixth largest moon of Saturn. In reality, it's not that large, just 314 miles across. In other words, this moon is small enough to fit inside Arizona. Ooh, we should try that. Well, interestingly, when the Cassini space probe first arrived at Saturn, researchers were expecting Enceladus to be a frozen ball of ice. But what they saw was plumes of icy particles and water vapor erupting from geysers on the moon's surface. It was clear that there was a massive ocean between the moon's rocky core and its icy shell. Then there's Jupiter's moon Europa. Scientists think that this world is one of the most promising places in the solar system when it comes to searching for new life forms. That's because Europa has a huge saltwater ocean as deep as 40 to 100 miles. And even though it's under a layer of ice that is likely to be 10 to 20 miles thick, it's still potentially habitable. Astronomers believe that plumes of water might erupt from cracks in the ice shell and release the contents of the moon's ocean into space. The temperature, pressure, and chemistry are very different on Europa, and astronomers aren't sure yet how the ice behaves there. That's the main reason they haven't figured out yet how deep or large the water reservoirs on Europa are and how long they need to refreeze. But out of all the places where we could find water in the universe, the most bizarre is probably open space. In 2011, two teams of astronomers discovered a cloud of water floating freely among stars. It was the largest and farthest reservoir of water ever detected. So this massive cloud of water vapor surrounds a black hole, but not just any black hole. This one's a quasar, located 12 billion light-years from Earth. The conditions around this quasar must be really special to create such an enormous amount of water. This cloud contains 140 trillion times the volume of all the water on Earth. That's enough to give every person on the planet a whole planet's worth of water 20,000 times over. Sounds wild, doesn't it? But there's something even cooler. Astronomers think this water cloud formed just 1.6 billion years after the universe began. This discovery is yet another sign that water has been around all over the universe, even in its early days. But here's the kicker. Until they found this, Scientists had never detected water vapor so far back in time. Sure, there's water in our Milky Way galaxy, but most of it's frozen solid in ice. This discovery really pushes the boundaries of what we know about water in the universe.
Something is happening on the red planet! Scientists believed that they knew nearly everything about its atmosphere, but a NASA rover has discovered something unexpected. There's more oxygen on Mars than they thought, and it behaves in weird ways. In the spring and summer, oxygen levels go up even more, and no one knows why. Now, you might think that when there's oxygen in an atmosphere, it's mostly because there's life somewhere around, like trees on Earth that produce oxygen through photosynthesis. But on Mars, it's not that simple. Non-living processes can also create oxygen, so we can't surely say that its presence means there's life on Mars. Mars has long been one of the main candidates when it comes to looking for signs of extraterrestrial life. Back in the 90s, scientists announced they had spotted potential proof there could be life on Mars because of microbes they had found in a meteorite that had arrived from the red planet. It looked like they had found fossils of bacteria. They actually stumbled upon tiny crystals of magnetite in the meteorite, which they believed could only have been produced by living organisms. It was such a mind-boggling discovery. People were excited, but many were also skeptical. It didn't prove there really was life on the red planet. Maybe there was life there a long time ago. The meteorite is thought to have originally formed on Mars billions of years ago, and to have landed on Earth thousands of years ago. Skeptics soon started to pick apart the evidence and eventually found some things that didn't make sense. For example, these magnetite crystals. No one could be sure how they formed. Why do they have to be bacteria? Some research has shown they could be the result of shock waves. Recently, the Perseverance rover has collected a couple of new rock samples from the Jezero crater on Mars. The theory says that about 3 billion years ago, before the red planet lost most of its atmosphere and basically just dried out, there was a big lake with a river flowing from it in that area. Whoa, what a great environment for life! Perseverance studied mud samples it had found on the bottom of the evaporated saltwater lake. Scientists were amazed to see a record number of sulfate molecules, something we usually find in mollusk shells on our home planet. Such organisms evolved a couple of 100 million years ago, but maybe there was a time when some of their space ancestors lived in water bodies on Mars. Mars has weaker gravity than Earth, which means these weird species could have got really big there, way bigger than their Earth cousins. Gravity plays a significant role when it comes to limiting the size of organisms. Bigger organisms need more energy to move against gravitational forces, but the creatures that may have lived there long ago are just a mix of hypothesis and our imagination, something that's still really hard to prove. Meet the Curiosity rover, another robot NASA is using to explore Mars. Curiosity has been in charge of measuring the composition of the atmosphere of the red planet for many years now. The rover has discovered that it mostly consists of carbon dioxide and a little bit of nitrogen and argon. The atmosphere of Mars has only 1/10 of 1% of oxygen, since, as far as we know at the moment, Mars doesn't have plants that could produce enough oxygen. But Curiosity has also discovered anomalies no one can really explain. It's found out that there are spikes in oxygen levels in the Gale crater during the Martian spring and summer. Every year, oxygen levels go up and down in unpredictable patterns there. What's even more interesting is that the oxygen spike is similar to a seasonal spike in methane, which is a gas we often associate with life on Earth. No wonder scientists are scratching their heads and wondering if there's a connection between the two gases, and if they both come from the same source on the Martian surface. Is there something big that breathes there? Come on, we'll be happy even with some small space worms in the soil. There's a type of salt called perchlorates in the Martian soil. Some scientists believe perchlorates might be responsible for the strange spikes in oxygen levels. But like with most things we know about space, it's just a theory. Also, scientists think that perchlorates breaking down in the Martian soil release oxygen too slowly to cause and explain the sudden increase in oxygen levels. One of the suspects is hydrogen peroxide, which is like water's unstable cousin. Hydrogen peroxide forms when sunlight breaks up carbon dioxide and water vapor in the Martian atmosphere. It can seep into the soil and stick to particles underground, which means it forms some kind of oxygen storage tank. Some data even show there are pockets of subsurface water in the Martian soil that may be hiding enough dissolved oxygen to actually support life. But even if the hydrogen peroxide could stay in the soil for millions of years, it would still only explain a small part of the increase in the level of oxygen. So you can't blame it for the whole thing. We can also take a look at an old experiment from the 1970s, where scientists found that moistening the Martian soil caused it to release a lot of oxygen. However, they did this experiment at a warmer temperature than the planet's average. And again, it doesn't explain how the oxygen spike keeps happening every year. None of the clues we have seems to fit the case. Mars may not have enough of its own oxygen, but it's possible to make this gas there. NASA conducted a small experiment where they tried and managed to produce oxygen on Mars. MOXIE is a device that can make oxygen on Mars. It managed to produce enough oxygen for an astronaut to breathe for 100 minutes. This awesome device worked in pretty tough conditions, at night or during the day, at extreme temperatures, and during the crazy dust storms the red planet is known for. Despite all this, MOXIE still kept up with producing high-purity oxygen. MOXIE is a clever device that can make oxygen on Mars by taking in carbon dioxide from the planet's atmosphere and heating it up to incredibly high temperatures. This allows the device to pull oxygen atoms from the carbon dioxide and produce breathable oxygen gas. If we want to use MOXIE to make enough oxygen for human missions to Mars, we need to make a bigger version of the device. But if we make it bigger, we might have trouble keeping it at the right temperature and making sure it heats up evenly without breaking. The ultimate goal would be to create an oxygen device that could continuously support a human mission for about 400 days. With a bigger version of MOXIE, we'd have enough oxygen to support crew members and even propel a return rocket to our home planet. When you see the dusty red surface of Mars, you can't say it's a place that hides liquid water underneath. Some say it's too cold for water to exist on Mars anyway. But there are stories that there could be a hidden world of liquid water, just like subglacial lakes in Antarctica. And to find out more, we might have to drill down about a mile beneath the surface. Unfortunately, it's not going to happen anytime soon. But in the meantime, scientists have been using a spacecraft called Mars Express to study radar reflections around the southern pole of Mars. The reflections seem to indicate there could be liquid water, and the planet's interior might be keeping it warm. But some claim it might just be rock. We hope there are underground lakes on Mars because it would be a perfect spot to look for life. After all, scientists have found bacteria living in subglacial lakes on Earth. But we don't know for sure how deep they are, or if they're just small veins of water in the ice. Only time and more exploration will tell.
Imagine a world where the red, barren landscape of Mars is transformed into a lush and verdant garden. A world where water flows freely, carving canyons and creating lakes and oceans. Can we achieve such a world by pouring the Earth's water onto the surface of Mars? And don't rush to say no. Let's explore this possibility. Alright, let's say we could magically transport all of the water on Earth to Mars. This supersized game of water pong would be crazy in both engineering and logistics. So how do we even do that? First of all, we're talking about millions and millions of gallons of water, which is no small feat. We would need some really big tanks to get all this water off the Earth. We would also have to figure out how to launch it all into space. this would require some serious rocket technology, as well as a lot of fuel. We could probably create an entire fleet of spacecraft specifically designed for the task. Just imagine that! A fleet of giant water tankers packed with tons of carefully harvested water, blasting off from Earth's surface and hurtling through space at unimaginable speeds. Wouldn't that be a cool sight? Now, another way. Probably a better one would be to launch a large number of smaller missions over time, each carrying a smaller amount of water until enough of it has been transported to Mars. So, let's say we manage to do all that. What happens next? After we get to Mars, we'd need to distribute this water all across the planet. We could use a network of underground pipes or some special drones to transport the water to different locations. This is just some basic things, and as you can see, we already need a lot of planning and resources. Moreover, a crazy operation like this would require a massive coordinated effort from scientists, engineers, and space agencies all over the world. And let's not forget about the costs. No wonder that scientists don't really consider it a viable plan. But the scale of this operation isn't the only problem. Hypothetically, let's say that we figured all that out and poured the Earth's water on Mars. Now what? Well, believe it or not, it would be almost completely useless. Our main challenge will be the atmosphere and current climate of Mars. Mars is a dry desert with an atmosphere that's only about 1% as thick as Earth's. This means that any water poured onto the surface would quickly evaporate. It would be pretty hard to create a stable environment when the entire lake can go poosh in a matter of seconds. And if the water doesn't evaporate, then, on the contrary, it will turn into ice. Mars' surface temperature is well below freezing. Thin atmosphere only makes things worse. Another challenge is that Mars has a very weak magnetic field, which means it has little protection from the solar wind. Solar wind is a stream of charged particles that are constantly flowing out from the sun. These winds are pretty dangerous. They can strip away any water that's put on the Mars surface. Also, the solar radiation on Mars is much stronger than on Earth. This would make it even more difficult to maintain any liquid water there. And finally, don't forget that we also need to purify this water to remove all the bacteria before drinking it. But let's not give up. If we stay super optimistic, we can still try to solve these problems. Basically, we need to find a way to maintain liquid water in one place for a long time and make sure that it doesn't freeze or evaporate. So how do we do it? There are a few ways we can go about it. Number 1, insulation. We could wrap all the water containers in insulation materials, like foam for example, or some reflective materials that can help to keep the water from freezing. Number 2, heating. We could use various heaters and devices to keep the temperatures above freezing, even thermal blankets. Although this would require a lot of energy and would be a difficult task. Number 3, underground reservoirs. We could dig a large hole and cover it with a transparent material to allow sunlight to pass through. This would help keep the water warm and insulated. Number 4, salinity. Adding a small amount of salt or other dissolved minerals to water can lower its freezing point. Although we'll need much more salt for things like lakes, and this method isn't the most efficient. And finally, number 5, building a greenhouse. We could build a greenhouse or some other structure that can trap heat and create a more Earth-like environment. This option is probably the best one. After all, a greenhouse would also help us to grow various plants or other organisms. Yay, life! Alright, great. Let's say we've discovered some way to store water on Mars and keep it there in a liquid, lukewarm state. What now? What impact would this have on Mars? Actually, this would be great. If we were to pour all this water on Mars, it could have drastically changed the climate of this cold, red desert. First of all, we could create a so-called greenhouse effect. It's when gases in a planet's atmosphere trap heat, causing the planet's temperature to rise. And yeah, this is pretty bad for Earth, but for Mars, whose temperatures jump between 70 and -200 degrees Fahrenheit, it would be awesome. This could cause the atmosphere to thicken and lead to the melting of the polar ice caps. Wouldn't that be awesome? Mars would begin to gradually turn from a lonely desert into Earth 2.0. It also means that the planet's atmosphere will change. For example, the weather patterns. Clouds could form on Mars, rains would begin to fall. And rains, as we know, transfer water from one region to another, which would mean they could water plants if they appeared on Mars. But all of this is pure speculation. We can't be completely sure what kind of impact pouring water on the Martian surface would have on the planet's climate. Perhaps, to create this greenhouse effect, we would need much more water than what we can transport. But if despite all these challenges, we had succeeded with our mission and made Mars much warmer and moist, could life have been finally born there? Unfortunately, that would still be pretty unlikely. Yes, water is very important for creating life, but that's not all we need. The composition of the Martian soil isn't very conducive to supporting life. The soil is mostly made of minerals called regolith, which are composed mainly of dust, sand, and other materials that aren't very good for plants. Theoretically, we could terraform Mars. Terraforming is a gradual, slow change of the planet so that it becomes suitable for our life, but this would be a very complex, long, and costly process. Oh, and by the way, what would happen to our Earth after all that? We took quite a lot of water, didn't we? From Earth's perspective, transporting water to Mars would require an enormous amount of resources, including energy and different materials. And the amount of water we'd have to spend would be staggering. The loss of such a large amount of water from Earth's own reserves could have a significant impact on our planet, especially in areas where water is already scarce. So basically, this is a really bad idea, no matter how you look at it. Yeah, it may sound interesting, but it's not a viable plan at all. It would require too many resources, too much money, and it wouldn't even be worth it. That's why scientists and space agencies don't consider this idea seriously. Besides, there are many other more realistic and achievable goals in the field of Mars exploration. For example, we can keep studying the planet's geology, atmosphere, and potential for past or present life. These studies would help us to find some resources that could support future human exploration. Overall, we need to answer many more questions about Mars before we even begin to consider colonizing it. So let's keep an eye on scientific news and updates.
Uh-oh. Something is nearing the surface of the planet. It looks like a fireball hurtling closer and closer at a truly incredible speed. Soon, it becomes obvious that the collision is inevitable. Bam! The impact leaves a huge crater. It evaporates thousands of cubic miles of solid rock, and it also sets off a series of terrible natural disasters. Yeah, I know what you're thinking. You believe I'm talking about the catastrophic collision that occurred around 66 million years ago on Earth. You know, the one that's responsible for the extinction of non-avian dinosaurs and 3/4 of other life forms on our planet? But no, the disaster I'm talking about happened on a different planet. Scientists think that our close neighbor, Mars, once experienced the same catastrophe that struck Earth. It happened around 3.4 billion years ago. An asteroid collision might have caused a mega tsunami on the red planet, similar to the one that caused the Chicxulub impact on Earth. Scientists have identified an impact crater on Mars that was probably left by a comet or asteroid collision with the surface of the planet. Most likely, the space body landed in an ocean in the Martian northern lowlands, and the impact was so powerful that it caused a mega tsunami. Before the latest studies, the exact location of the impact crater wasn't verified. It was just a theory. To confirm it, a team of astronomers simulated a comet and asteroid collision in the area where they supposed the impact crater was. They even named this crater Hall. Hall is 68 miles across and lies in a region that is almost 400 feet below the supposed sea level. Anyway, the simulations formed several craters of the same size as Paul. One of the simulations claimed that these craters had been left by a 5-mile-wide asteroid that had encountered strong ground resistance. The other simulation showed that the craters had been caused by a bit smaller asteroid that met a weaker ground resistance. But according to both simulations, the impact crater was almost 70 miles in diameter. and the collisions produce mega tsunamis up to 900 miles away from the center of the impact site. The simulations also help scientists estimate the height of the tsunami. It was about 820 feet tall, almost as tall as the Eiffel Tower. The authors of the study also suggest that the Pole crater might be similar to the Chicxulub impact crater on our planet. The Chicxulub asteroid, as we now know it, is believed to come from the outer reaches of the solar system. This space body was at least 6 miles across. It crashed into the shallow seawaters near the Yucatan Peninsula. This splashdown was so powerful that it left its signature on the entire face of the planet. In 2021, researchers found out that the collision had carved mega ripples into Earth's crust in the region of modern-day central Louisiana. An even newer study suggests that the asteroid also triggered a tsunami so devastating it eroded seafloor sediments half a world away. The team of scientists remodeled the events of the first 10 minutes after the impact, and the model showed that the asteroid had produced waves up to 30,000 times greater than one of the largest tsunamis people have ever recorded, the Indian Ocean tsunami that hit Indonesia in 2004. The collision displaced so much water that it created a wave almost a mile high. That's like 2 Burj Khalifas, which is the tallest construction in the world, stacked one on top of the other. And of course, all that empty space didn't stay empty for long. The ocean gushed back to fill the crater. But in the process, it only ricocheted off the crater's rim, which produced even more waves. After that, tsunami waves that were more than 33 feet tall traveled around the world at a speed of 3 feet per second, lashing at all coastlines on their way. Imagine a 3-story building rushing up to you. No wonder the largest and fastest moving waves occurred near the impact area in the open waters of the Gulf of Mexico. Those rose more than 330 feet tall, which is taller than the Statue of Liberty, and moved at a speed 10 times greater than more distant tsunami waves. But back to the Red Planet. Some experts think that not 1 but 2 mega tsunamis could happen on Mars. They could be triggered by a pair of meteor impacts that were several millions of years apart. Between these 2 collisions, Mars went through a period of climate changes. As a result, liquid water on its surface turned into ice. In other words, the first asteroid impact most likely produced waves composed of liquid water, and the second tsunami was probably formed by rounded chunks of ice water. By the way, the largest asteroid to have ever crashed into Earth might not actually be the one that ended dinosaurs. A much more catastrophic collision likely happened about 3.5 billion years ago. New evidence scientists found in northwestern Australia suggests that the asteroid I'm talking about was 12 to 18 miles across. It struck Earth at an immense speed, releasing an unimaginable amount of energy. Now, this made me think, what if something like that happened these days? More than 30,000 objects that are circling Earth these days could potentially crash into our planet. NASA considers around 1,500 of them to be potentially hazardous. These space rocks are the remains left after the solar system was formed some 4.6 billion years ago. For example, in 2004, astronomers discovered a huge asteroid nearing Earth. The first observation showed that the chance of the space rock hitting our planet was less than 3%. The asteroid was named Apophis. It's more than 1,200 feet across and weighs about 20 million tons. It's supposed to streak across the sky on April 13, 2029. Apophis will pass at a distance of 19,000 miles away from Earth's surface. But even though this space rock might miss our planet in 2029, it doesn't mean it won't return 15 years later in 2036. If such an object hits our planet, the consequences will be unpredictable. They can vary from shattered glass and broken windows to most life forms getting wiped off the face of the Earth. And it'll probably affect the internet. Now that last thought is truly scary. But luckily, modern technologies are likely to help us avoid any catastrophic consequences. Experts have developed several ways to prevent a real-life disaster movie from happening. For one thing, we could use a spacecraft to knock this visitor from outer space off its course. Or it could somehow be blasted into pieces. Scientists could also slow the thing down with the help of concentrated sunlight. Or people could tug it away with a gravity tractor. That's a theoretical spacecraft that can influence objects in space without touching them. In sci-fi movies, a huge asteroid often sneaks up on Earth and turns out to be a nasty surprise to astronomers. It hurtles toward our planet at breakneck speed and gets discovered just weeks or even days before the collision. In reality, scientists are constantly watching all large objects in Earth's neighborhood. It means there would be plenty of time to do something before the inevitable happened. There are 3 kinds of missions scientists could prepare at short notice. Type 0, when a heavy spacecraft hurtles toward the intruder with one single goal: to knock it off its course. In this case, astronomers would have to rely on the already available information. The Type 1 mission would involve a scout. It would be launched first to get more close-up information about the space rock. Only after that, the main spacecraft would be launched. With more precise information, its journey would be way more productive. And if scientists chose the Type 2 mission, they would send a scout and a small spacecraft at the same time. The spacecraft would knock the asteroid a bit off its course. Then the scout would collect all the necessary information. Based on this data, the spacecraft would finish its job with a more fine-tuned second push. If none of these methods work, people could try going deep underground or even build a shelter on the ocean floor. But in this case, we'd need to find sources of energy that could help us survive for at least several decades. Plus, people would have to create a life support system that could somehow keep air and water fresh. It seems like NASA and China are each planning to send humans to Mars. Both space agencies have tentative plans to launch the first crewed missions by 2033, right when Mars and Earth are playing a game of tag. And that's not all. Other missions may happen in 2035, 2037, and beyond. The ultimate goal is to build a Mars habitat for future exploration and research. So, how are they going to do that? Well, let's find out. Now, traveling to Mars isn't as easy as hopping on a rocket. The distance between our planets can change a lot over time, ranging from around 35 million miles to 250 million miles. And even with our best technology, it takes 6 to 9 months just to get to the red planet. So, a round trip to Mars could mean spending 3 years away from Earth, dealing with extra radiation and floating around in microgravity. But NASA's Jet Propulsion Laboratory has some exciting news. Scientists have been working tirelessly to design a minimal architecture mission to Mars. They're thinking that 2033 is the perfect year to make it happen. So here's the deal. Every 15 years, the rocky planets, Venus, Mars, and Earth, align just right to create a cosmic sweet spot. The mission will make the most of this rare alignment and perform an epic gravity assist maneuver using Venus. It's like getting a boost from a planetary slingshot. We'll speed up our spacecraft and reduce the need for making our own propulsion. The report also talked about some really cool ideas, like using nuclear power for spacecraft engines and using Martian resources to make things. These technologies could make space travel faster, protect astronauts from radiation, and make it easier to live in space. They might even let us make resources and fuel right on Mars. So this is how the plan goes down. First, we'll launch a spacecraft towards Mars. It'll spend around 30 days in high orbit, exploring and gathering valuable data. Then it's going to head back to Earth, also swinging by Venus for a quick visit. So this whole adventure will last approximately 570 days, which is just 1.6 years. And a shorter adventure means less exposure to radiation. Now keep in mind, this mission will focus on orbiting Mars rather than landing on its surface. It's just a stepping stone, paving the way for future landing missions. Just like Apollo 8 mission orbited the Moon before Apollo 11's historic landing. Landing on Mars by 2033 might be a bit too ambitious due to funding constraints, but who knows? If all goes smoothly, it could become a reality. Now for the coolest part. We don't need fancy new technologies or vehicles for all this. We'll make use of existing ones that are already in production or being studied for the Artemis moon program. Now let's break down our Mars mission vehicle, a big puzzle of many parts. And guess what? It was put together by a community of space enthusiasts back in 2017. That's right, it wasn't the scientists who produced it first. But now, this isn't just some fantastic idea anymore. Most of these things are already becoming a reality, being made or planned by NASA. So let's take a look at this concept. First, we have the Orion spacecraft. This is the spaceship that will take the crew to the orbit around Earth and bring them safely back home. It's like a super fancy space taxi, and it might be the most powerful taxi to ever exist. It's combined with 3 powerful propulsion stages, and we're also using a special fuel that doesn't need to be ultra cold like in the movies. Next, there's the Earth departure stage. This is an important part of the mission. It helps us make a powerful thrust that sends us on our way to Mars. Then we have Mars transit habitat. This is where the crew will live and hang out during their journey to Mars. Like a cozy space house with all the things they need to be comfortable. And finally, the Mars orbit insertion stage. When we reach Mars, this awesome thing will help us slow down and enter its orbit smoothly. It's our maneuvering expert. Even the Mars transit habitat is being developed and might even be tested in a few years. That means we're on track to have the whole thing ready for our amazing Mars mission by 2033. In other words, it's all about working with what we've got and making it happen. Now, let's talk about the plan's timeline. Mid-2028, the action begins. First, we'll need to do a couple of test flights. We'll send 2 stages ahead of time to make sure we can come back to Earth safely. These stages will join together like 2 spaceships becoming best buddies. They'll orbit the red planet and then come home. To do all that, we'll use powerful rockets and 13 commercial launches. It's going to be a huge space party. Late 2032. After all that, we launched the fully assembled Mars mission vehicle to high Earth orbit. So far, this is an empty vehicle that awaits astronauts. If all is good, then it'll be ready for the final check. March 2033. Time for our brave crew and their Orion spacecraft to join the party. We launch them and they dock with the Mars mission vehicle in Earth's orbit. They'll make sure the whole lot is just right before we head to Mars. Flexibility is important, so we can adjust our plans if needed. April 2033. Everyone's ready for the adventure. We perform a powerful burn, like a big push that sends us on our way to Mars. The crew will travel for about 200 days. November 2033. Finally, the crew reaches the red planet. Once they're in Mars orbit, they'll spend about 30 days exploring and doing awesome space stuff. Mars will be our playground. When it's time to return home, they'll say goodbye to the stage that helped them get into Mars orbit. Then their vehicle will meet up with the 2 stages we sent ahead. Remember these space buddies? And after that, it will take us about 340 days for the crew to come back to Earth. This is where we'll use the gravity of Venus to slingshot around the Sun. To keep the equipment and crew at the right temperature, we'll have a sunshade that will protect us from the sun's heat since we'll be really close to it. In the end, Orion will re-enter Earth's atmosphere and splash down in the water. What a heroic ending! And this would be just the beginning. Our awesome team has another plan for the bravest adventurers out there. It's called the Conjunction-class long-stay mission. It launches in April 2033 and lasts a long time, 950 days. That's more than 2.5 years, with 550 days spent in Mars orbit. It requires fewer launches from Earth, but has some different challenges, like spending more time in microgravity and dealing with increased radiation. So we'll need some real space heroes for this one. But of course, there are some major hurdles to overcome before we can make all this happen. Experts closely looked at NASA's Journey to Mars program and found that the plan needs some serious changes. There are a few high-risk areas, like life support systems for long missions, using solar power for propulsion, making oxygen on Mars, and so on. They're also worried about timelines, funding, and many other things. So, according to them, sticking to a deadline of 2033 might be impossible with the current plans and budgets. Even aiming for 2035 carries significant risks and possible delays. But hey, space exploration has never been easy, right? With realistic determination, anything is possible. Most likely, the idea of sending people to Mars will be realized before 2040. NASA is working on finishing the plan and details to make this possible. So, even though we still have some tough nuts to crack before we can make it a reality, the dream of sending humans to Mars is exciting. It's a thrilling adventure full of challenges, discoveries, and the spirit of human exploration. So, let's show the universe what we're made of. And that would be mostly carbon.